right, so hopefully you looked ahead and gave this one a try. Okay, in this case, we've got independent events again, and that's because we're told. Now we're told that they're independent. Okay, so Ron is planning a trip to Paris for Thursday and Friday. A quick check of the weather report says that in Paris, the probability of rain on Thursday is 0.2, and the probability of rain on Friday is 0.4. And we're told to assume that these probabilities are independent of each other. And we're asked, what is the probability that Ron will see rain on at least one of the 2 days? All right. Well, we've got two stochastic events, right? One of them is it going to rain on Thursday or not, right? So we can draw that in a tree. It's either going to rain on Thursday, so I'll call that R sub t, R sub t for rain on Thursday. Or it's not going to rain on Thursday, right? I'll call it R sub t complement. The probability of raining on Thursday, we're told, was 0.2, and the probability, so the probability of not raining would be 0.8, right? Because they have to add up to 1. It's either going to rain or not rain. So, so the probabilities have to add up to 1. All right, so that's Thursday. Now Friday, it's either going to rain on Friday or it's not going to rain on Friday. So I'm going to call R sub f raining on Friday. R sub f complement then is not raining on Friday. And I have the same two possibilities, whether or not it rains on Thursday or not. So R sub f and R sub f complements. It's either going to rain or not rain on Friday. Now we're told that there's a 40% chance of rain on Friday, so 0.4, right? Which means that the probability of not raining is 0.6, right? 0.4 and 0.6. All right, so we want to know what's the probability that he will see rain on at least one of these 2 days. So let's try to identify the combination of outcomes in which we have rain on at least one day. So I'm just going to use my highlighter here. So here it rains on Thursday and it rains on Friday. Okay, so that's at least one. It's actually two, but that is one of the events that we're interested in. Is at least one means either one or two. So that would be one possible way that we could get at least one rainy day. It could rain on Thursday and then not rain on Friday. That would be another event that we'd be interested in. And then the other one would be if it doesn't rain on Thursday, but then it rains on Friday. Okay, that's another event where we get rain on at least one of the 2 days. Okay, now we're not interested in the last one where it doesn't rain on either day, at least not for now. We'll come back to that one. All right, so if I just look at all the ways that this event could happen that I'm interested in, so I can calculate the probability of rain on Thursday and rain on Friday. Rain on Friday by just multiplying the probabilities, right? I'm just going to have 0.2 times 0.4, which gives me 0.08. The probability of rain on Thursday and not rain on Friday, right? That's just going to be multiply the probabilities down the branches. 0.2 times 0.6, we get 0.12. Probability of no rain on Thursday and rain on Friday, is just going to be 0.8 times 0.4, okay, which gives me 0.32. All right, so if I want to know what's the probability of rain on at least one day, it can happen any of these three ways. So I'm just going to add up these probabilities. I'm just going to find the probability of rain on at least one of these days. So actually, I'm gonna leave that out. I'm just going to write it this way: probability of rain on at least 1 day. Okay, let's write it the long way. It's just going to be the sum. So I'm just going to draw a line because I'm just going to add up 0.8, 0.12, and 0.32, which gives me 0.52. So a 52% chance, right, that I'll see rain on it, or that Ron will see rain. I'm not going to Paris as much as I would like to. I don't get to go to Paris. So 52% chance that he would see rain on at least one day. Now, there's another way we could get that. And you may have already recognized that, because rain on at least one day is the complement of rain on no days. Okay, and rain on no days would be this branch, right? And it seems like it would be easier just to calculate the probability of that particular outcome where we don't see any rain, and then subtract it from 1, because we know that if we don't see any rain, then we saw rain on at least one day. So we could also do this by looking at the probability of no rain on Thursday and no rain on Friday. Just by multiplying those probabilities, we get 0.8 times 0.6. So 0.48, right? And now what we want to know is what's the probability of rain on at least one day, right? So I could actually write that as this way. Rain on Thursday or Friday or both, right? And that would be 1 minus the probability of no rain, which is 0.48. Okay, so again, I get the same thing either way, 0.52, right? And that makes sense because, you know, that something's got to happen. And all the probabilities of everything that could possibly happen have to add up to 1. All right, so my answer is 0.52. All righty, I got one more example to go through, and I'll see you in the next video.